Hey guys, so this video is about solving and graphing absolute value inequalities with a greater than sign. Okay, so we'll start by remembering that the absolute value of a number is that number's distance from 0 on the number line. Okay, so if I had the absolute value of x, it has to be greater than 2. So I'm going to mark where it's equal to 2 just with open circles, because we can't include 2. We don't want that distance to be the same as 2. We just want it to be greater than 2. So if I start at that indicated value of 2 and negative 2, and then where do I go to get away from 0? If I want my distance from 0 to be bigger, to be greater than what it is at 2, which direction should I go? Well, over here I would need to come this direction. And over here I would need to go this direction. Now both of these inequalities that I am talking about cannot be true at the same time, right? You can't have a number that's less than negative 2 and greater than 2. It's impossible. It's one or the other. And so that word or is important. So these are called or statements. So if I wrote these two inequalities, I would say that x has to be less than negative 2, or x has to be greater than 2. Okay, let's talk about that in a different way. So again, your phrase to remember, less than and greater or. All right, we're not going to talk about less than. We talked about that in a previous video. Anytime you see a greater than sign, these are or statements, because they can't both be true at the same time. It's either less than one thing or greater than another. So when that happens, we're talking about the numbers outside of two values. So let's look at another example. Say the absolute value of x has to be greater than or equal to 3. Okay, well, on a number line, this is 0. We'll call this negative 3 and 3. Okay, so if I want an absolute value or a distance from 0 to be bigger than or equal to 3, we could start at negative 3, and then I'm going to have to go away from 0 here, or positive 3 and go away from 0 here. So just like the other video where we talked about less than, being able to rewrite these as inequalities from absolute value to an inequality is really important. So we have two separate things going on here. X would have to be less than or equal to, in this case, negative 3, or, sorry, I don't know why the pen keeps doing that, or x would have to be greater than or equal to positive 3. So I kind of want to point out that there is one inequality when we write these that looks very similar to what we started with. And then there's another one that's completely backwards. The sign's flipped and we have a negative instead of a positive. That always happens. So let's look at an example. So again, step 1, we have to isolate the absolute value. So we want this part to be by itself. So we should add 2 to both sides to make that happen. So absolute value of 4m is greater than 16. And now we have greater, so I know it's going to be an or statement. I'm going to go ahead and write the word or. And I have either exactly what I'm looking at there, 4m is greater than 16, or the complete opposite, 4m is less than negative 16. All right, then we just divide. We have to solve each of those. So this one, if I divide by 4, I get m is greater than 4. Or, in this case, if I divide by 4, I get m is less than negative 4. So we'll start with this graph. M is greater than 4 would be 4 open circle, because I'm not including 4. It's not or equal to, and everything greater than that. Or negative 4, and everything less than that. Okay, let's do another example. Okay, in this example, the absolute value is already by itself. There's nothing being added, subtracted, multiplied, or divided outside of that absolute value. So we can go ahead and write our or statements. So again, I'm going to write exactly what I see. Negative 8a minus 3 is greater than 11. Just drop the absolute value. Or negative 8a minus 3 is less than negative 11. I think I might have read that backwards on this other one. The first one is negative 8a minus 3 is greater than 11, or negative 8a minus 3 is less than negative 11. So now we just solve each of those. So I'm going to start with the first one. If I add 3 to both sides, I get negative 8a is greater than 14. Now, don't forget, in this case, I'm going to write this out. When we divide by the negative, it flips our inequality sign. So this one is actually turns to less than 14 over 8. So that would be 7/4. Okay. Or, in this case, I'm going to add 3 to both sides. That gives me negative 8a is less than negative 8. And when I divide by negative 8, again, it's going to flip that inequality sign again. So I have a is greater than positive 1. Okay, so negative 7/4, I don't know, somewhere in here. And a is everything less than that. And then a has got to be greater than 1. So there you go. There's your absolute value of inequalities. Make sure you let me know if you have any questions. You can comment below or ask me in class. See you guys.